I'll be looking at this question in this video. A bullet of mass 20 grams moving at a speed of 200 meters per second towards a block of mass 2 kg at rest. Now, this bullet did not just stop when it arrives at where the block is. It actually strikes the block. And here they said if the bullet is stopped in the block after 0.2 seconds, that is after traveling, after moving through the block in a time of 0.2 seconds, calculate the deceleration of the bullet in the block. You see that now, the bullet, let's just show that by this illustration. The bullet is here, very, very small. The mass is just about 2 grams. Sometimes, okay, here it is 20 grams. Moving at the speed of 200 meters per second. You can see that now. It's not the mass that is the matter, it's the momentum because of the high speed. That's why I can do a lot of damages in the tracks, a block or an object. Okay, so this bullet travels with this high speed, and then let's say here's a block of mass. Let me just draw a cross section of the block. That's the side view of the block. These are the side view. So when it hits the block, let's say it penetrated the block a few distance, which we are going to find. Let's say this is distance D that is penetrated by the bullet in the block. Now the question says, suppose this block is fixed, it does not move at all. We have to calculate the deceleration of the bullet. Work must be done by this block to actually bring the bullet to rest, and so that energy can be conserved. Because before this bullet hits the block, it has kinetic energy. So when when it strikes the block and when it's brought to rest eventually, it must have lost its entire kinetic energy, and that must appear in other form of energy so that energy will be conserved. Going by the law of conservation of energy, that energy cannot be created nor destroyed. Now, we want to look at that deceleration. Now, before this bullet enters the block, it has an initial velocity. This 200 becomes initial velocity. Let's assume that this 200 meters per second stays constant throughout, except gravity. Sometimes when the distance is too large, the bullet may begin to move in this direction, owing to gravity, kind of, you know, projectile motion. So let's say the bullet stays in this direction until it reaches where the block is, which means the initial speed of the bullet is 200 meters per second. Okay, so let me write that down as u is 200 meters per second. And you know that when this bullet is brought to rest eventually, it has a final velocity of 0 because it's brought to rest in the block. And the time it's spent moving through the block is 0.2 seconds. So we can find the deceleration. I call that A. That is required parameter, in this question. So I can borrow from the first equation of motion, V equals U plus acceleration times time. Of course, you know this, some of previous videos have gone through the derivations of these equations of motion. So if you don't really know that, you are just entering this video the first time, I'll say you take a look at that video. So initial velocity is 200 and the final velocity is 0. So I have the 200 plus A times 0.2 seconds. So that gives you minus 200 equals 0.2 times A. So my acceleration divided both sides by 0.2, acceleration gives me minus 200 divided by 0.2. That gives me 1000 meters per second squared. It's a very large acceleration. Okay, the negative sign means that I'm dealing with acceleration. Therefore, the deceleration is 1000 meters per second squared. Remember that when you are stating acceleration, you ignore the negative sign. So that's the deceleration of the bullet in the block. Now, the next one, you calculate the resistance that is offered by the block to bring this bullet to rest, to stop it. Now, the resistive force F is going to be equal to mass times deceleration according to Newton's second law of motion. So that resistive force, the mass of the bullet is 0.02 because 20 grams converted to kilogram. I'll divide that by 2. I'll divide that by 1000. That gives me 0.02 times 1000. Okay, so that will give me 20 Newton. If I'm not mistaken, you can confirm that. So that is a resistance that is offered by the block to decelerate or to bring the bullet to rest inside the block. Okay, now the next question says the work done by the block in bringing the bullet to a halt, in bringing the bullet to rest. Work must be done so that energy will be conserved. Now, that work done is converted from the kinetic energy of the bullet, all right? So that energy will be conserved. Work done by the block is equal to kinetic energy of the bullet. Okay, so what is the kinetic energy of the bullet? That is half mv squared. So that gives me half times mass of the bullet 0.02 times the speed, which is 200 squared. So that this gives me, this cancel this, 0.01 times 200 squared, that is 40,000. 40,000. So multiply that gives you 400 joules. So this is the work done by the block in bringing the bullet to a halt, in stopping the bullet, in decelerating the bullet while it moves through the block. Okay, I'm sure this is very clear. Now let's see another condition still following from this question, that a bullet of mass 20 gram moving at a speed of 200 meters per second towards a block of mass 2 kg. Now let's see, suppose this time around, if the bullet is brought to rest in the block after penetrating a distance of 12 centimeters, calculate the average resistive force that is offered by the block to stop the bullet. Okay, in this case, the distance d is given. Okay, distance d is 12 cm. I'm going to change that to meters. That is 0.12 meters. Okay, now the kinetic energy of the bullet, half mv squared, is equal to force times distance. That is to say, this force times distance is the work done by the block in decelerating, in bringing the bullet to rest. You know, it must be derived from the loss of Ke of the bullet, because the bullet is going to lose some amount of, the kinetic energy it had before, especially when it eventually comes to rest. And that Ke is now translated to the work done by the block in bringing, in decelerating the bullet. So I have here half times 0.02 times 200 squared is equal to force times distance 0.12. So this gives me, of course, I got this before as 400 is equal to F times 0.12. So that the average resistive force 400 divided by 0.12. If you have your calculator, you can quickly punch. So that gives you 3,333 Newton into the nearest whole number. Okay, so that is now, how about if it was possible? Suppose that after the impact, the block and the bullet move with a common speed or velocity. Now I want to calculate this common velocity. Calculate their common velocity. Okay, and I'm sure you understand that this is a form or a kind of inelastic collision after the impact. Let's say the block was not fixed to the ground, and then have the bullet initially moving towards the block with a speed of 200 meters per second. Of course, the mass of the bullet is 20 grams, and then when it strikes the block, this is the block, both of them move together in this direction with a common speed v. Of course, you can see here that the bullet is embedded. It didn't penetrate or pass through the block completely. It became buried in the block, and both of them start moving together in one direction with a common speed. So since this was at rest, we can see its initial velocity, let me call that u2, is 0. The initial velocity of the block of the bullet rather, let me call that u1, is 200 meters per second. So I can use the principle of momentum conservation, that the initial momentum of the bullet plus the initial momentum of the block is equal to their final momentum. That is to say, since they move the common speed, it means the final velocity of the bullet is v, the final velocity of the block is also v. That gives me m1 plus m2 multiplied by the common speed v. Okay, so this gives me 0. This is 0.02 times 200 is equal to 2.02, because the mass of the block was given as 2 kg in the question. Okay, so if you add that together, 2 kg plus 0.02 gives you 2.02. That's the total mass times v. So this gives me 4 is equal to 2.02 times the final speed. Therefore, the final speed is 4.0, or just 4, divided by 2.02. So I quickly divide that. 4 divided by 2.02 gives me 1.98 meters per second. That means both block and bullet will begin to move together with a speed of 1.98 meters per second. Okay, so that is that for this question. And then the next video, the applications of Newton's third law of motion. See you in the next video.